When dealing with functions, the next skill that I'd like to work on with you is working on function notation, okay? Function notation is actually just a very slick way of telling you how I want you to evaluate a function. So for example, this is a function rule, okay? It's telling me f of x, it equals 3x plus 2. So if I want to evaluate f of x for, let's say, x equals 2, all I'd have to say is evaluate f of 2. And that means just plug in 2 everywhere that you see in x. So again, it's just a slicker way of being able, for me being able to tell you how I want you to evaluate functions. So let's actually do that. Let's find f of 2. Well, f of 2, they said, all you need to do is plug 2 in everywhere you see x in that formula. So 6 plus 2 is going to equal 8. So f of 2 equals 8. Okay, now essentially let's also think about what that means. So if f of 2 equals 8, you can actually write that as the point at when x is 2, the y value or the function itself is at 8. Okay, so just various ways you can see that answer written. Okay, so f of 2 being 8, really what that means is when x is 2, your y value or your function's value is up at 8. Okay, and that's really all that we're going to be doing in this lesson. Okay, just exploring this idea of evaluating functions. So our next function is h of x equals the absolute value of x minus 2 plus 5. So the first one I'm going to do, I'm going to focus on h of 4. So I'm going to plug 4 in. So 4 minus 2 is going to leave me 2. Well, absolute value of 2 is just 2. So we get 7. So h of 4 is 7. So what that means really is when I have an x value of 4, my function is up at 7. So the point 4, 7 would be on that graph, okay? I would see it in the graph of that absolute value function. And h of negative 1. So now let's plug in negative 1. Negative 1 minus 2 more is going to be negative 3. The absolute value of negative 3, with the absolute value of something, is going to make it positive. So here, I'm going to get 8. So again, what is this communicating to me? What is this telling me? Well, it's telling me that the point negative 1, 8 would be on that graph. If I were to graph this thing, that would be one of the points, right? My input, my x is negative 1, output is 8. All right, how about this next one? So g of 2, so let's plug in 2 everywhere I see an x. Now here we have to be very careful, okay? So notice how I only put the parentheses around the 2, because the 2 was the only thing I was plugging in. When we're evaluating things, another thing to always watch out for is you always do exponents first, right? So for that first one, I have a 2 squared, which is 4, and then the negative turns it back into a negative, or turns it negative. 3 times 2 is 6, then a minus 7. So negative 4 plus 6 is 2, minus 7 is negative 5. So again, if I ask you to write this as a point, when I have an x value of 2, my y value is negative 5. That is what this thing equals, okay? Equals negative 5. Then g of negative 3. So I'm going to plug -3 everywhere. So remember, only put the parentheses around exactly what you are plugging in. And now we're going to do exponents first. So in that first thing, -3 squared is a positive 9, but that negative turns it back negative again. 3 times -3, then a -7. So -18 minus 7 is going to be -25. So that is what this thing is going to equal, okay? When I evaluate it, it equals -5. And if I asked you to write that as a point, you can picture that as I'm plugging in a -3 and I'm getting out a -25. All right, and this next one, plugging in 11. So here, square root of 22 plus 3, so the square root of 25, which is just going to equal 5. So my answer here is 5, but again, I'd like you to understand that that would mean the point 11, 5 is on that graph, okay? I would like you to understand that that is what this means. When I find that 5, it means that 5 is paired with the 11. When I plug in -1, so I just go through and evaluate this. Square root of 1 equals 1. So my answer here is 1, right? That's what this thing is going to equal. But I'd like you to understand that it's paired with, when I have an x of -1, my function is sitting up at 1. Okay, an important connection to have here. So let's do one more example. So tickets to a concert are available online for $35 each, plus a handling fee of $2.50. The total cost, C of t, is a function of the number of tickets bought, t. Write a function that models the cost of the concert tickets and evaluate the function for 4 tickets. All right, so what's happening here is I'm writing this function, C of t. So t is my number of tickets, and every ticket is $35 each. Okay, so $35 each is going to look like that, right? I buy 1 ticket, that's $35. I buy 2 tickets, that's $70. So it's connecting the 35 to my t, okay? The number of tickets is determining how many times I pay that $35. And then usually you have this handling fee, right? This cost that you just have to pay because you're ordering the tickets. So one-time fee has nothing to do with how many you're buying, it's just there. So that is what I can use as a function to model this situation. Okay, 35t plus 250. And now the question is, now they want us to evaluate for 4. Okay, how much are we spending? What is that cost going to be if I'm buying 4 tickets? So all I have to do is plug in 4. So 35 times 4, it's going to be 140 plus 250. So how much are you spending? Well, you're spending $142.50. So again, thank you for joining me through this. After you have all this written out, then make sure that you go and you start practicing on the worksheet paired with this.